15. All right, 15 is k to the third minus 4k squared. Somebody asked yesterday if you changed them to x, was that okay? And that's okay. If you see it better like that. Watch out for your placeholders on this one. I start with 3. All right, so outside I need a 4, yes? Yes. Yes, you guys show me your work. It's so much less work than long division.
I didn't show you all of my work.
3, 2, 1, and then the constant. So if you didn't have the placeholder, grab it, multiply, add, multiply, add, multiply, add. Looks like I have a remainder and then nothing else but x squared. So this equals x squared. And you could do plus negative 2 over, oh, I did x. I didn't do x. I mean, it doesn't matter. K squared, you could do over k minus 4, or you could do k squared minus 2 over k minus 4. Either one of those two will work. Other question. Huh? You knew it long division. Why would I do it long division? Constant. Remainder constant x squared. If it kept going, it would be x to the third and so on. Charlie, just for you. M minus 1 into 9m to the fourth minus 9m cubed. I need a placeholder for the second power. Yep. What do I multiply m by to get 9m to the fourth? Multiply round. So 9m to the fourth minus 9m cubed. And I subtract. Negative 9m cubed minus negative 9m cubed, of course, gives me 0. So since that gives me 0, and since that is 0, I need to get 2, since this has 2 terms, I need to keep dropping until I have 2 terms. And now I have 2 non-zero terms. So now I can do the process again. What do I multiply m by to get negative 8m? Negative 8, and I multiply that around negative 8m plus 8, and subtract. 12 minus 8 is 4, so I get 9m cubed minus 8 plus 4 over m minus 1. What else? Nothing? Everybody good? Once? Good. And by the way, you'll do tonight, you'll do through at least, unless we get further than I anticipate, at least through 15. So any that I skip, you'll do for homework. But you don't want to be doing those while I'm teaching the new stuff and skipping around, because then you're going to come back and not know how to do the other stuff that I'm telling you. But we're going to do 1 and 2 together right now. So just as a review of synthetic division here, we have a problem. X to the fourth plus 3x squared plus 4x minus 1 divided by x minus 1. So divide that real quick and see what you get. And let's talk about some terminology here and what looks like what. I'm going to do it, but I'm not going to talk through it, so don't look up until you finish what you got. Is that what you got? Yes or no?
No.
Did I do it wrong? All right. Yeah, everybody got that? All right. So what is the quotient here? What does quotient mean? The answer that you got. That's exactly right. Quotient is the answer you got. And I forgot I can actually pull this up and do it on here. Don't forget your placeholder here. 1, 1, 1, 1, 4, 4, 8, 8, 7. So it's the answer that you got, right? And we're going to leave the remainder off because it's asked for that separately. So we have 1x to the third plus 1x squared plus 4x plus 8. And my remainder is 7 over x minus 1. Everybody good with that? All right. Notice this is the same problem. I want you to find f of 1 and tell me what you get. Now, what does that mean if I say find f of 1? Y'all can do this. It's not a trick question. Replace every x with 1 and tell me what you get. What'd you get? 7. Now notice on here, these are exactly the same, right? When you divided by x minus 1 here, or you plugged 1 in, what do you notice? Get the same remainder. So this equals the remainder here. This is what we call the remainder theorem, okay? And all the remainder theorem says is that if you divide by I actually have it typed on here. When you divide by a factor x minus a, okay, so if I could synthetically divide it, then I could plug that a in, and that would just give me the remainder every single time. Okay, that is the remainder theorem. I don't know if y'all like these kind of guided notes or not. I'm not always a fan, but I typed these up because this wasn't in the curriculum, but it's in the standards, so I kind of made these. But if you don't like them, we'll be on to something new next time. But it kind of walks you through.
Opposite of A, though?
Okay, but it's minus, so yes and no. So if I plugged in here up here, if I did f of 5, that would tell me the remainder when I divide by what? X minus 5. So now as I come down to this next one, if I find, oh, this was f of 5 here. If I find f of 5, that's going to tell me the remainder whenever I divide by x minus 5. But find f of 5 and see what happens. What do you get? Negative 125 plus 75 is negative 50 minus 5, negative 55. So f of 5 is negative 55. So what should my remainder be? Negative 55 over x minus 5, right? That's what I have left. Synthetically divide that real quick because you should be able to do that fairly fast now and see if that's what you get for your remainder. Because you take the remainder and put it over what you divided by. And since I plugged in 5, then what I'm dividing by is x minus 5. What do you notice? It's the same as it should be because that is the remainder theorem. Everybody clear on what remainder theorem does? Gives me the value of the remainder without actually having to divide. I can just plug in. Everybody okay? Can you all tell me what we're dividing by when we do that? Do you understand where the x minus 5 is coming from? You understand where everything's coming from? Everybody good? No? If you plug in 5, then it'll give you the remainder when you divide by x minus 5. If you plug in negative 3, it'll give you the remainder when you divide by x plus 3. Whatever that number is, x minus that number, that's the remainder when you divide by that. All right, I'm going to skip 4 for you to do. And 5, we'll do 6 together. Because 6 looks a little bit different. 15 is due tomorrow through 15, and then 16 through the rest will be due on Thursday. Mm-hmm. All right, look at number 6. Try this one on your own. Find the factor, or find the remainder in f of 2. Whoa. So check out. Just to show you that if I divide, I get the same thing. Uh-oh. What'd I do? Oh. Forgot my placeholder. So remainder here is 32 over x. Everybody good? See what we're doing here? All right, now we get to the good stuff. Ready? This is going to be important because we're going to be looking for things that have a remainder of 0. Because when something has a remainder of 0, that means it goes into it evenly. And something that goes into anything else evenly is called a what? A factor, right? Do we agree? Give me, for instance, give me one factor of 6 that you know. 3. Everybody agrees 3 is a factor of 6. Why is 3 a factor of 6? It goes into it with no remainder, right? We can say that 3 is a factor of 6 because 6 divided by 3 is 2 with no remainder, right? There's no remainder there. That's by definition what it means to be a factor. So I can also have a factor of a polynomial. Now you see how this is fixing to tie back in with factoring like we've been doing? I'm using that factor word and throwing it around pretty loosely, but haven't really talked about what it means. All right, so tell me what you know. If 3 is a factor of 6, tell me what you know about 2. 2 is also what? A factor. Because when you divide by a factor, you get another factor. Does that make sense? Okay. Oh, well, that's the next question. When you divide a polynomial by x minus a and you get a remainder of 0, then x minus a is a factor of that polynomial. But not only is that a factor, but the quotient, which is what you get, is also a factor. Does that make sense? When you divide by a factor, you get a factor. Positive. In fact, you could write these two factors together, which is what we're going to be doing, and you could say that 6 could be written as 3 times 2, as the product of two factors. And that's really where we're going with this and what we'll be doing. And that's what the next part is talking about. So to factor completely, we divide by a factor and then write it as a multiplication problem with its other factor, which is just what you get when you divide. All right, 3 ways to determine if you have a factor. Tell me, what do you think? What's it mean to be a factor? Go into it evenly with no what? Remainder. So I could divide synthetically and get no remainder. I could do long division and get no remainder. What else could I do? How else could I tell that there's no remainder that we just learned about? If I plug that value into F and I get 0, that tells me there's no remainder. That's that remainder theorem. So any one of those 3 ways will work to tell us if I have an actual remainder. All right, so when you get to the next section, here's where the rubber meets the road. Here's the good stuff. They give us a factor. We have to fully factor. Okay, so here's what we're going to do as we do this. We're going to divide by the factor, and these are written down in the previous part, but it's a little confusing. Divide by that factor that's given. All of these will be able to be divided synthetically, every single one of them. Okay, so go ahead and divide and see what you get. Remember, if it's a factor, I better get 0 as a remainder because that's what it means to be a factor. All right. Nothing new yet. Now the new part, I'm going to write it as a multiplication problem. What exactly do I mean by that? I mean, take the answer that you got. All right, this was the factor, right? This is just like that 6 divided by 3 equals 2, and I wrote it as 3 times 2. Well, this divided by this equals x squared plus x minus 6. So instead of writing it this way, I'm going to write it as these two multiplied together. So x squared plus x minus 6 times x plus 5. That is the same thing as this. Do you agree and see why? Does it make sense to you? We're doing the same thing we do with numbers, we're just doing it on a bigger scale. Now this looks like something you've done before and you can finish doing. So the last thing I'm going to do is I'm going to factor all the parentheses completely and find the zeros. Can I factor this first one any further? Does that factor?
Yes.
What multiplies to negative 6 but adds to positive 1? 3 and negative 2. 3, negative 2. Does x plus 5 factor any further? No. There's my factored form. None of the parentheses factor down any further, so that is my factored form. Essentially what we're doing here is we're factoring by division instead of factoring using a previous method. What are the zeros here? Let's do one more. Pick one up through 11. What you want me to do?
Good morning, Charlie.
How about 11 since that's last, so we can type back in too. You try this one, then we'll come together and do it together. Y'all get it? Remember on these, if you don't get 0 as the very last, as the remainder, back up and start again because you've done something wrong. So now I'm going to write it as a multiplication problem. I've got x minus 3, and I've got x squared minus 3x plus 2. And now factor. What multiplies to positive 2 but adds to negative 3? Negative 2 and negative 1. So factored form looks like this. What are the zeros of this function? 3, 2, and 1. Yes, no, maybe so. All right, last little thing. And this just plays on this. It's just the same thing, just a little backwards. Here we're starting with a factor, right? But what if I started with a 0? Like, what if I didn't tell you this, but I told you x equals 3 is a 0? Could you back up and say, oh, well, if x equals 3 is a 0, that means a factor is x minus 3. That's where they're getting with this next little part, okay? So when you plug in a 0, you should get no remainder. That's what we've been talking about. But x minus 0 is a factor. We talked about all that. Okay, so go down. This time I'm given a 0. So what I'm going to do is I'm going to change the 0, and I'm going to write 0 like this, to a factor. X minus whatever that 0 is. And then I'm going to follow the steps of the previous problems. Which means if x equals 0 is one of the zeros, that means the factor that goes with that is what? Y'all can do this. X minus 4. So now follow all the steps that we did before. X minus 4 is a factor. Divide it, factor it all the way, and find all the zeros. So I put the 4 on the outside. 1, negative 8, 4, 48. Because look, the directions for this just say find the zeros, given a 0. Drop it. And I should get 0 on the end because that's what it means to be a factor. That is by definition a factor. So now I have x minus 4 times x squared minus 4x minus 12. Can you factor that polynomial, that quadratic, any further? Yes. What multiplies to negative 12 but adds to negative 4? Negative 6 and 2. What multiplies to negative 12x squared but adds to negative 4x? It's just factoring. And I shortcut it because I got a 1 in front. What happens? Well, let's finish this and then I'll talk about what happens. So my zeros are x equals 4, x equals 6, and x equals what? There you go, negative 2. You see, a lot of this is just everything all put together. It's not really a whole lot of new stuff. What happens if you had gotten to this point and this didn't factor any further? Huh? Well, you would put this 0, but you'd still do something with this. How do you solve a quadratic that doesn't factor? Oh, this is not forest fish. So that could come up also. All right, that's all I got for you. Y'all look forward to tears. As did calculus this morning. I must be doing a poor job. Go through 15 for your homework. Why is that?